Now that we've covered some basics of probability, we want to look at the issue of whether two events are independent or dependent. Does smoking affect your chance of contracting lung cancer? Does a country's poverty level affect the average life expectancy of its citizens? Is there a link between alcohol consumption and gender? And does your height affect your IQ? For all of these questions, if the two variables affect one another, then those are called dependent events. If they do not influence one another, they are called independent events. So, do you think smoking and contracting lung cancer are independent events or dependent events? Do they influence one another or not? Does a country's poverty level affect the average life expectancy of its citizens? Are average life expectancy and poverty level, are they independent or dependent variables? Is there a link between alcohol consumption and gender? Is there a link between the variable alcohol consumption and gender? Are they dependent or are they independent? And does your height affect your IQ? Are height and IQ related or not? If they are related, that means they are dependent. If they are not related, then they are independent events. Well, personally, I would say probably that smoking and contracting lung cancer are connected, meaning they are dependent events. I would guess that countries' poverty level and average life expectancy also are dependent events. Alcohol consumption and gender, I don't really know if there's would be a connection between those or not. And I don't think there's any connection between height and IQ. So those would be independent events. However, that is not scientifically sound, just saying what my opinion might be. We need to somehow quantify the idea of independence and dependence. To do that, we need the concept of conditional probability. And here is its definition. The probability that an event B occurs after an event A has already occurred is called conditional probability and is denoted probability of B vertical line A. Now, that's not how you actually read it. The way that this thing is read is probability of B given A has occurred. So probability of B given A has occurred. So it's as if this vertical line is the word given. Let's see if we can work on that first question. Is there a relationship between smoking and lung cancer? Are they dependent events or independent events? So to do that, we first need to get down this language of conditional probability. So let's let L represent the event of having lung cancer and let S represent the event of being a smoker. Then the meaning of this notation, which again is read as P of smoker given having lung cancer, is the probability of someone being a smoker given that they have lung cancer. P of L given S is the probability of someone having lung cancer given that they are a smoker. So that's the language, but let's understand the difference between these two, because these two are not equivalent. Essentially, the event in the back can be thought of as the restriction. So if you want to know what the probability of S given L is, you want to look at specifically people that have lung cancer. So you're restricting it to people who have lung cancer. And then amongst the people that have lung cancer, you want to see how many of them are smokers. Over here, the restriction is S. So instead of looking at all people that have lung cancer, we're going to specifically look at all smokers in this case. That's the given part. And then amongst the smokers, we want to know how many of them have lung cancer. We could then compute a probability based on that. In summary, to find something like the probability of S given L, you restrict the world to L, the set of all people who have lung cancer, and then as a subset, you find out which one of those are smokers. Then you can compute a probability. To find the probability of L given S, you restrict your world to the set of all smokers, And then among the smokers, you find out who of them have lung cancer, and then you can compute a probability as well. Now that we have conditional probability defined, we can actually define formally the notion of independent events and dependent events. So in this case, we're calling our events A and B. Two events A and B are independent if and only if this is true. The probability of A given B equals the probability of A. They are dependent if the probability of A given B is not equal to the probability of A. So we want to make sense of why it's defined this way. So basically, if these two things are equal, that means that A, the probability of A occurring when B has already occurred is the same thing as the probability of A occurring whether B has occurred or not. So basically, this is saying that B really doesn't have an effect on A. Then you would call them independent. Whereas if you go to compute the likelihood of A occurring given that B has already occurred, and that's different than the probability of A occurring where you're not worrying about B, then that means B actually had an effect on A. Then you would call them dependent events. So let's now try to answer that initial question. Is there a relationship between lung cancer and smoking? Well, this information here is I gathered from some resources. It's a little bit difficult to nail down. It can vary depending on the journal you're looking at. But in general, the likelihood of an American, if they're chosen at random, having an American adult, that is, having lung cancer is 6.5% chance. And then from another resource, I found that when you're strictly looking at smokers, the likelihood of them having lung cancer is 11%. So, using those numbers, are smoking and lung cancer dependent or independent events? Well, notice here, the probability of L given S is not equal to the probability of L. Since they are not equal, this means that these are dependent events. So we can first conclude that these are dependent events, but we can say even a bit more. Specifically, the probability of L given S is greater than the probability of L, since 11% is greater than 6.5%. So this means you are more likely to have lung cancer given you're a smoker than to have lung cancer in general. So you are, or a person that is, more likely to have lung cancer as a smoker than you are in the general population. And what I mean by general population is I'm talking about all Americans, those that smoke and those that don't. So the key thing to realize here is that you are not comparing the likelihood of having lung cancer given a smoker given to the likelihood of having lung cancer given not a smoker. This is not the probability of L given not S. So it's probability of L, which means you're talking about the general population. Now that we have the notion of conditional probability and independent and dependent events defined, let's now go through a new problem where we actually have to compute the probabilities ourselves.